Hello, everyone. I'm Federico Lucas, mobility analytics engineer at Nomon, and I'm happy to guide you through this video where we're going to explore a real use case where mobile phone data was used to generate origin-destination matrices. This real use case study on the application of mobile phone data for generating OD matrices was conducted in Brazil, in the Salvador metropolitan region. This region is located in the northeast of the country and is bordered by the Atlantic Ocean. The area has a population of 3.6 million people, of whom 2.5 million people live in the state capital, Salvador, which is the fifth most populous capital in the country. Here we have a view of Salvador, featuring the Farol da Barra, an icon of the city. This project was carried out under contract from the local Department of Mobility, which mainly plans public transportation. Right now, Salvador is implementing a series of bus rapid transit corridors, also called BRT, and updating travel flows is a powerful tool for adjusting services to meet latent demand. The department is also interested in understanding how mobility works on atypical days, which is why they were looking for alternatives to traditional household surveys. The project thus brought together a telecom operator company, Claro, which has about 34% market share in the region. It brought together Nomon as an expert in processing, merging, and enriching telecom data to obtain flows of people. This task, which my colleagues Andrés Miguel and Ignacio Blasco were especially involved. And finally, TTC, a local partner providing unique knowledge of the city. The objective of the project was to establish a systematic methodology for generating OD matrices and applying it to both a typical period, April of 2024, and an atypical week, February of 2024. The study of the atypical week focused specifically on Carnival, one of Brazil's biggest festivals, which brings people of all backgrounds into the streets to dance and celebrate day and night. Salvador is known throughout Brazil as one of the main destinations for the festival, which closes streets and changes the city's pace for at least 5 days. Nomon's mobility insight solution was used to generate the origin destination matrices. This figure shows a high-level view of the mobility insight solution. The main data sources for this project were mobile phone data from Claro and land use maps and social demographical data from IBGE. Then, data pre-processing, cleansing, and quality checks started once the anonymous data was received from Claro. Nomon stores and processes it on a cloud server, and the records are sorted, grouped, and compressed, allowing for more efficient data management in later stages, as well as reducing calculation times. The process of data cleaning and error debugging is essential to ensure the quality of the initial data, preventing possible errors generating at the data source, and from distorting the results obtained with mobility pattern extraction algorithms. We then have the sample selection, in which we construct the sample to be used in each study. Users are selected whose mobile phone activity provides sufficient information to reliably infer their activity in travel diary without losing any relevant activity during the time that they were present in the study area. This selection is made according to criteria relating to the number of records generated and the time between records. The construction of the sample, therefore, involves a compromise between quantity and quality. At this stage, the place of residence is also identified by analyzing the behavior patterns of users over several weeks or months. The identification of the place of residence is used later in the sample expansion process. We then go into the continuity model. The process of generating travel and activity logs is responsible for transforming cell phone records into mobility information, constituting the core of the technical solution. The objective is to generate an activity and travel log for each anonymous identifier included in the sample and for each day of the study. This topic includes 2 tasks. The first one is identification and the characterization of stays and activities. To identify these user stays, let's say their presence for a certain period of time in a given location, consecutive records in the same cell, or in a set of adjacent cells are analyzed, and depending on the spatial analysis unit used as a reference. Those locations where the individual is detected for longer than a certain threshold are identified as stays. Next, the stays that correspond to an activity are identified, distinguishing them from intermediate stops between stages of the same trip. And the second part is the identification and characterization of trips and stages, or the legs of that trip. Once the stays and activities have been identified, the trips made between the different activities and the different stages that constitute them are identified. We then go on to the points of interest, home locations, usual environment, and the purpose of activities, and hence trip purposes, are identified based on the longitudinal analysis of the activities carried out by users during several weeks, such as location, duration, recurrence, together with the information on land use and points of interest. The activities are classified into the following categories. Home, well, this is the user's place of residence, and it's essential for the identification of trip purposes, as well as for the sample expansion. You have work and education, which is usually a recurring activity of significant duration that is carried out in a place other than the place of residence. This is an assumption that we make, and this will be the location of the full-time work or activity, education activity. Then we have other frequent activities, the rest of recurring activities outside the place of residence that do not meet the criteria to label them as work or education are labeled as other frequent activities. And finally, you have other non-frequent activities, which is the rest of activity location. Then we go on to the expansion of the sample to the total population. Once the activity and trip diaries have been generated, the expansion can be done based on gender, age, and place of residence. In this way, the valid mobile phone sample population can be expanded to the entire study population. Then we can calculate common aggregates, in this case, origin-destination matrices. The final step consists of aggregating this data from individual travel and activity diaries to generate travel matrices for additional demand indicators according to the segmentations defined in the scope of this project. And we end off with aggregates to indicators, which was produced to guide and extract useful information. I'll be presenting these in the following slides. We've calculated travel production and mobility indices, hourly distribution of trips, trip volume by purpose at origin and destination, origin-destination heat map, and a map of attractive and productive zones. Let's move on to some of these results. The typical week is always shown in green, and the carnival week in pink. On the x-axis, we have Monday to Sunday, and the last one is a holiday study, Labor Day, which occurs in May. The bars represent trip volumes, and the lines show the trip generation rates. We can observe that both volumes and rates are higher in the typical week. Carnival starts on Saturday and ends on Wednesday. The trip volume on Carnival Monday and Tuesday is similar to a typical Sunday. Whereas Saturday and Sunday of Carnival, we have a mobility quite typical for a normal weekend. It's fair to point out that this is the mobility of only the residents in the city. Now let's analyze the distribution of trips throughout the day. In light green and pink, we have Saturday and Sunday. It's clear that typical weekdays in dark green have the three common peaks: the biggest in the morning, when most people wake up and go to work, a smaller peak around lunch between 12 and 1 p.m., and a final peak in the evening. On weekdays, the curve is smoother, and the pink curves also show less pronounced peak, though they are still present. An interesting analysis is to look at how the pink curves at night are much higher than on weekdays, especially on Carnival Saturday, which is the light pink curve clearly standing out. Another classical analysis is the purpose distribution along the day. In the morning, we observe a high volume of home-based activities as origins, while at night, there's a peak in home activities as a destination. On the other hand, the work trips show the opposite pattern: a peak in the morning as a destination and a peak at night as the origin. The other category, which is trips frequent, different than work, captures a mix of hybrid work patterns. In both charts, the curves follow the expected pattern with the blue line, but with an extra peak around lunchtime. To also mention another subject regarding the connection of the OD matrix, in this heat map, we see the relationships between all zones in the project. We note that there are some small blank spots. These blank spots represent OD pairs for which no one is recorded as making that trip. From an empirical perspective, we know the heat map should be more colorful, And that is exactly what we get when we use mobile phone data. If we did the same analysis for a home-based survey, you will get many more blanks than when this technique. Lastly, let's add some geographical analysis. Here we have 4 maps showing the entire metropolitan region painted in shades of green. On the left side, the map represents trip productions, that is the number of trips originating from each zone. On the right, they show trip attractions, or the number of trips with destinations in each zone. The 2 maps at the top show trips during the morning peak. We observe a lot more green concentrated in this area, which is the heart of Salvador, the city center with all the jobs and the beaches. At the bottom, we see the afternoon peak, where everyone is returning home. Cross-analyzing these maps, if you draw a cross, you'll see the maps are quite similar. So that is production in the morning, an attraction in the evening, an attraction in the morning, and production in the evening. This clearly highlights the pendulum-like behavior of trips, especially in the metropolitan regions where jobs are concentrated in the capital. So that's it. Thank you, and do not forget to check the complete case study document.